Right, this video is about energy and bonds or bonding. So up here, I'm going to use this reaction as an example. This is called the Haber process. Every day, tens of thousands of tons of ammonia is made around the world. Extremely useful product. Okay, in this reaction, one molecule of nitrogen, 3 molecules of hydrogen turn into 2 molecules of ammonia, and the heat change here is plus 92. That is, it is endothermic. To make this reaction, you have to put energy in. So let's have a look at bonds. Here we have our molecule of ammonia with a nitrogen-nitrogen triple bond. Here we have our hydrogen molecules, 3 of them, with one hydrogen-hydrogen bond. Over here we have 2 ammonia molecules, and the only type of bond in there is a nitrogen-hydrogen bond, and there are 6 of them. So we have 6 nitrogen-hydrogen bonds being made. We have 3 hydrogen-hydrogen bonds being broken, and we have 1 nitrogen to nitrogen triple bond also being broken. Okay, that's extremely stable. So the key concept here, which you must always state in your answers, is that bond making absorbs energy. You must put energy into these bonds to break them. You must supply energy. So where they do this, a good energy supply is needed because they need a lot of energy to break the bonds, and overall the reaction absorbs energy. So you put energy in. So bond breaking is endothermic. Now, once these bonds are broken, the atoms are going to come together in this pattern and make the ammonia molecules, and the bond making is energy releasing or exothermic. So that's our major concept. Bond breaking is a process that's endothermic, whereas bond making is exothermic. And in this reaction here, we see that overall 92 kilojoules per mole is absorbed. So that means that breaking these bonds takes 92 kilojoules per mole more than is given out when these bonds break. So if a reaction overall is endothermic, it means the bond breaking process takes more energy than is released by the bond making. So in this reaction, the bond breaking energy is greater than the bond making energy, and therefore overall reaction, the whole reaction is endothermic. So that's the basic concept there, which you need to be able to explain. So summarizing that, just quickly, if the energy of bond breaking is greater than the energy of bond making, then the reaction is endothermic, as in this situation here. If the energy of breaking bonds is less than the energy of making bonds, then the process will give out energy, exothermic. Okay, and the figure given there, the energy change, is the difference between the two things there. So if it's positive, the bond breaking process uh, is bigger than the bond making energy, and it absorbs heat. If it's the other way around, if the energy released is the bond making bigger than the energy absorbed in the bond making, it would be exothermic. I haven't put an example of that on the book. Thank you. Goodbye.